My name is Alfred.
Oh, I'm Dustin.
Fix your hair.
I'm Francisco.
And this is our science project, and I'm Luis Pinozo. That's Alfred, right there. He's neighing. And so is Dustin. He's twerking.
The most humorous thing that happened, or the most humorous thing about the class, was the wave. I think it was the wave. The wave activity was pretty humorous because, like, the fact it took us, like, the whole block to figure out. It was, yeah.
The most amazing thing about the learning class is when we talk about black hole. Black hole is a place in space where gravity pulls so much that even light cannot get out. So how are they formed? They're formed like stars. It was a really interesting topic.
What you would think of when someone says physics? I think, like, when someone says physics, I think of, like, motion.
How physics will fit into the rest of your life. Physics is going to be everywhere.
Number 6. What do you want to pass on to next year's students taking Miss Troney's physics class? 3 rules. Be respectful to Miss Troney, do the work, and be on time.
Alright, hi guys. I'm going to be talking to you guys about energy. So, for the energy basics, there are 4 different types of energy. There's number 1, kinetic energy. 2, potential energy. And then gravitational potential energy, which is similar to potential energy in a sense. And then finally, the last one, elastic potential energy. Alright, starting off with number 1, kinetic energy. The energy an object has because it is in motion. So let's say I'm hitting a baseball like this. I have kinetic energy because I'm hitting the ball and I'm transferring the energy towards the ball, making the ball fly all the way. Number 2, potential energy. The energy an object has because it would move left if left on its own. No interference is very important. So, let's say I have a rock right here on the table. And if the table is gone, the rock would fall off and hit the ground. So, it has the potential to move, but it doesn't. But it can still move. Next, we have gravitational potential energy, which is the same as potential energy. So I'll just leave that out. And then finally, we have radiant energy, the energy in electromagnetic radiation. So first on the list is light, microwaves, X-rays, UV rays, and radio waves, TV signals, and cell phone signals. Those are all part of the spectrum for the radiant energy spectrum.
This is my topic about fields. Earth has a magnetic field that keeps it in balance with all the other planets, which the sun controls. It's pretty big, and it's a gas bubble. And it keeps all the other planets in orbit, which circulates.
Kinematics. Kinematics is how things move. So, kinematics have vectors. Vectors is a quantity that has both magnitude and direction. Yeah. It also has displacement, which is the length of a line path from start to finish with direction. Velocity is how fast an object goes from start to finish with direction. How fast. Or also known as velocity equals displacement over time. And acceleration. Acceleration is how fast the velocity changes, either a change in speed or direction, or also known as acceleration. Change equals change in velocity divided by time.
Alright, I'll be talking about dynamics. Dynamics is how things move. So Newton's first law is an object will remain at rest or moving with constant velocity unless an unbalanced force acts on it. And Newton's second law is if you place an unbalanced force to an object, that object will be accelerated, and the amount of change depends upon the object's mass. And then Newton's third law is for every force applied to an object, that object applies on equal but opposite force back. So equilibrium is when all the forces on an object are balanced. So what happens when an object is in equilibrium? The object either stays at rest or stays moving with a constant velocity.